Today I want to show you some DDS theory. DDS stands for Direct Digital Synthesis, and I want to show you this case that we want to generate a sinusoidal signal, which we also can present the unit cycle. In the digital world, we only can generate discrete values, for example, like this. And we also have a difference between the samples of TS. Also, the sample frequency, Fs, is 1 over Ts. We also can represent the samples in the unit cycle. For generating these values with an FPGA, we use, instead of calculating the values, which is very expensive, a lookup table. So we have some memory, for example, RAM or ROM, and the values are saved in the lookup table, where, for example, the first value corresponds to the first memory value, the second to the second, and so on. The input value is the address of this memory. So the output is, as we wanted, a sinusoidal signal. Now we want to look at the address. So when we just use a counter, then we get always the same frequency. But when we use a counter and a multiplication with a factor, then we can increase this frequency. For this purpose, we use a phase detector where we have two inputs. The first one is a clock, and the second one is some factor, let's call it k, where we can set the frequency. When the value k is higher than 1, for example 2, we not take every value here, but instead we use every second value. And therefore, in this example here, the output with a factor of k is equals 2, we get this sample. Then we also get this sample, but a sample earlier, which means here. And then the next sample would be this, which is here. And so we doubled the frequency in this case. In real applications, we use more than just these values here. When we look at the addresses, we have here the 0, 1, etc. up to 2 with a power of n minus 1, which we can set in the DDS compiler in Vivado. When we want to calculate the frequency depending on these parameters, we can use the formula F is equal to F clock times K over 2 with the power of n. And also we can calculate the value K, which is F times 2 with the power of n over the clock frequency. With this knowledge, you should be able to set up your DDS compiler in Vivado without any trouble. Thank you for your attention, and if you have questions, you can put them in the comments.